Hi, Robert Hamilton, or Rob. So it's very nice to meet you. Okay, with you. And I would like to talk with you about a very special piece, which is actually created by a very special instrument called Quartet.
Hey, Sandris. Good afternoon. Nice to talk to you too.
Can you just explain a little bit about the piece, or can you call the piece?
Sure. So I guess the piece we're talking about today is called Trois de la Grâce, Aimante, which is a virtual reality string quartet written in many ways like a traditional string quartet, and in many ways not at all like a traditional string quartet. As you mentioned, the piece is performed and displayed in virtual reality, with each of the performers wearing virtual reality head-mounted displays and using Oculus Touch game controllers to actually control virtual reality instruments, which are all versions of an instrument called Quartet, C-O-R-E-T-E-T, right? Pun intended, which is a virtual reality instrument system and networking platform that I built specifically for this piece, but then the instrument itself has been used for other performances and pieces as well.
Can you give some kind of background of the piece and the project?
Sure.
Commission.
Sure. My background as a composer and as a researcher for a long time now, for nearly 20 years probably, has been focused around this idea of using kind of advanced gaming influenced technologies in the realm of electroacoustic and electronic music composition and instrument design. And so it's something that I've been very interested in for years, is to how to harness the power of these fluid, graphically immersive, inactive technology technology to control and create music. I did a series of pieces dating back to around 2007, 2008, using more standard game engines, hacking existing games like the Quake engine and the Unreal Development Kit and the Unreal Engine to create kind of immersive game worlds that were themselves inherently musical. This piece itself was an attempt to get away from this idea in electronic music that a lot of us are very comfortable with, which is using electronics, we can create any kind of sound in any way with any kind of gesture or any kind of control system, which on the one hand is fantastic and is beautiful and allows us to be extremely creative using technology. And then on the other hand, it's kind of easy, right? In a certain way, it's that if you can do anything, well, you can do anything. There's no restriction. And often as composers and as creators, restriction actually increases our ability to be creative. And so for this project in specifically, I really wanted to try something I hadn't done before, which was to accurately, to some extent, create a virtual model of traditional instruments, or at least traditional instrument performance practices, to the extent that could I create an instrument in virtual reality that a performer who has tacit knowledge, who has a learned ability on a certain performance style, a certain instrument, physical, mental, conceptual, could their abilities transfer to this virtual implementation of the same concept to such an extent that they would inherently be better at it than, say, I would if I didn't play that instrument, or another non-musician.
Yes.
So the Quartet project was designed, was essentially, the idea was to create a suite of virtual reality instruments descended from bowed stringed instruments, the violin, the viola, cello, eventually a double bass. And in such a way, build them in such a way that they could commingle in virtual space and could perform together. And what better way to do that than a traditional string quartet, where four performers are very much connected musically, conceptually, physically in the same space. And so So this project came out of that ideal.
Yes, but regarding instruments, right? You somehow like, let's say, if we compare like traditional instruments and those, let's say, virtually created, in some way you amplified, right? The sound is different and opportunities are different, right? Can you tell the difference, or what you add, like as composer?
Absolutely. So by nature, things are different when they're representations of an actual physical object, right? In order to create a playable, say, violin in virtual reality, without adding extra accoutrement of physical devices, by nature, we have no physical tactile interface for our body, right? We have no string for which our bow will be pressing against, and the feeling of bow pressure, which is itself, one of the inherent driver of a bowed string sound. Similarly, we have no tactile feel for where our finger is interfacing the neck of the instrument and which string we're pressing on. So by nature, we have to create an abstraction of that instrument. It can't be the same thing. What we have to do is take the affordances offered to us in this technology platform of virtual reality and try to find corollaries, try to find maybe a metaphor for which we can use these affordances in VR without physical touch to drive parameters of a system that would traditionally be driven with touch. In Quartet, I made some efforts to make the instrument as lifelike as possible. The strings themselves are physical models of bowed strings, driven by the synthesis toolkit created by Gary Scavone and Perry Cook. Just a really wonderful set of physical models of how a string is actuated using certain parameters. And then I had to come up with different ways to drive that signal that didn't have that tactile haptic touch and feel. So what I ended up creating was an abstraction of an instrument. So certain parameters of the instrument feel very lifelike. As I move my hand up and down the neck of the instrument, I'm controlling a continuous pitch of a finger pressure on each finger on each string. As I make a bowing gesture with my right arm, holding a virtual bow, it feels very much like I'm bowing. And the gestures themselves translate very well. Those other parameters have to be abstracted, and so the model itself borrows from reality, but has to differ in many ways.
Yes, yes. And maybe you can say a little bit background of the project, who commissioned it, and when performance happened, how much time you need to make it all.
So this project was wonderful. The Quartet project and the commission for Trois de la Grâce Aimante came from Marco Siciliani and his group at the IEM in Graz, Austria. Marco, who I know you've interviewed on previously, the wonderful composer and researcher. He headed up this project called the Gap. So for essentially focused on gamified musical systems and performance practices. And initially, Marco asked me to come out and kind of view some of the other works that were being created and to discuss some opportunities. And one day while walking around the snowy streets of Graz on a long walk after a session in the studio, I came up with the idea for something that I wanted to commit a few years to. And that was, let's do something crazy. Let's work on the networking aspect of performers in VR, which traditionally has been difficult. It's not an easy challenge. And at the same time, let's do that by building an instrument model that inherently makes sense to put this effort into the networking concept of it. And so by the time I walked back to the IEM studios, after having many coffees around the city of Graz, I had this fully formed idea in my head to write a string quartet and build a series of instruments together, all as one project for the Gap project, and to perform it with the performers there. And then over the next 2 years, we realized that. I built the software. I composed one movement of a 3-movement string quartet. including graphical scores that you would see in many contemporary works, standard graphical score. And over the 2-year period, I rehearsed with performers in Grâce, and we premiered the piece. Actually, I'd have to go back and look at the date, but we premiered the piece in the studio, IEM studio in Grâce. It was wonderful. Regarding the technologies necessary to put on the piece, it's a fairly hardware intensive piece. 4 performers, each one wearing Oculus Rift headsets, each one having their own laptop computer to drive that system, because that's what's necessary with the standard Rift. Using 2 tracking towers and Oculus Touch controllers, so that they themselves are within a space, a VR space, a network audio server and a network game server. So essentially 6 computers, a network switch, and lots of power. So good fun.
And can you just give some kind of idea what is the central message of the piece, right? And how it's communicated? Because you're using very special instruments, right? I just guess that there is some kind of special idea behind the composition itself, right?
So in this case, the design of the instrument and the composition of the work were just inherently connected. The composition itself explores the abilities of the quartet instruments. The quartet instrument can be set up so that with a finger touch, can be configured so that the neck of the instrument is either a continuous fingerboard, similar to what we would have on a cello or a violin. It can also be set so that there are détentes or virtual frets that you would find on a guitar or some other instrument. Similarly, those frets can then be moved so that the scale of the instrument neck is not at all what one would expect. So the neck can be divided into a simple octave. It can be divided into a pentatonic scale, a whole tone scale, a whole number of different configurations. And so the piece itself was composed to both showcase these different configurations of the instrument. So leveraging kind of the way that the instrument itself could guide the performers on what notes they could play. And so to play between that and then pure freedom of expression as they can play any note that they want.
Yes.
All of this is guided with a graphical score, a traditional printed graphical score that communicates gesture and density. So different ways that the performers can play together are learned in rehearsal, and then the performance is done without a score, because in this case, wearing headsets, it makes it very difficult without additional technology to read the score itself.
Yes. So basically, right, I say, understand it, there was some kind of idea as well, just to show that how powerful this instrument could be, right?
Very much so. Yeah.
Yes. So and as I understand from you, that there is a lot of things that you can do with that instrument, more than with traditional, right?
Yes and no, right? There are the beauty of our traditional physical instruments is that one single solitary note can sound and fill up an entire room so well. Yes. And dealing with technology systems, while it's very easy to make loud sounds and it's very easy to make complex systems and sounds that are generated from a single touch or a single motion, that same kind of capturing of attention through resonance and through kind of just the physical attributes of a wooden resonating chamber are so hard to duplicate. So in a sense, I feel like I'm always operating at a loss. I'm always chasing that beautiful original sound, which the quartet instruments sound like bowed strings, but they sound like processed electronic bowed strings versus the purity of an instrument tone.
Yes, and where is the advantage, right? You said that there is some disadvantage, but where is the advantage, right?
The advantages is that the instrument itself has no restriction based on physics. The instrument range can be infinite, essentially, and there are sections of the piece where the performers actually play above the Nyquist frequency for the current sampling rate of the software, so that glitches and noises are introduced that are essentially nonlinear. They're non-controllable. So the ability to have these bursts of energy controlled by performers that are not inherently controllable, right? That's one of the wonders of dealing with electronic instruments, is that we can blend chance and randomization and nonlinear stochastic processes with control. So it's this back and forth, and the ability to sculpt both our sounds and the way that instruments are played dynamically in real time, that we can change these things, something that is much harder to do with a physical instrument. So the piece itself plays off of those abilities as well.
And just right as I understand, so that there is like that everything was in studio, so that there was no listener, right? The listener only can experience that piece in video format, or I'm wrong?
No, so the piece itself has been played in concert a number of times. Yes. It's performed like a traditional concert. In the videos, which I believe we'll share, the quartet itself is arranged on a concert stage. There's a projection of the virtual space behind them that showcases to the audience, at least a two-dimensional view of what's happening in the game space that all the performers themselves see. And sound itself is spatialized with one channel per instrument. At times, I've actually performed the quartet instruments using more channels than that, which is a whole nother interesting world to explore. Yes. And we've done the piece a number of times. We've performed it twice for audiences in Grâce with the same ensemble there. The piece has been performed in Mexico City by an ensemble. It's been performed in the south of France, in Marseille, by another wonderful ensemble. And so the ability for this piece to be performed like a traditional work has already been shown. Now, due to its technology heavy footprint, I, as the engineer / composer, really have to be there to set up the equipment, read the ensemble in, let them rehearse, show them how the piece works, and work with them in order to perform it. So it's a lot of work, but it works quite well.
Yes. So I understand, right? Basically, listening experience are created by videos, right? The one part. Second, you see it's all, let's say, it's just a gaming play where 4 people are playing, are using this Oculus Rift, right? And then there is a sound speakers in the room. That's the way how this listening or sensorial experience are created.
And it's what we see in these kinds of pieces often is the attention of the audience is forced to focus in 2 different spaces simultaneously while listening to one aural space that essentially combines the 2. And it's a really interesting thing that happens, whether it's the performers are in a virtual reality space or just in a game space, that in a piece like Quartet, I actually make an effort to superimpose these 2 spaces. So the virtual space, as the audience sees, they see 4 performers and their instruments seated around in a small circle in a similar way that a traditional string quartet would. In the physical space in front of the audience, the performers are seated in the same pattern, but they're actually facing away from one another because they can't actually physically see one another. Part of that constraint was due to the fact that they need to face the towers for the Oculus Rift controllers. But it creates a really interesting concept in that in the real world, the performers, while situated near one another, obviously aren't looking at one another, right? It's a little bit of kind of a play on their positioning. But then in virtual space, they all see one another just fine. They're actually moments of the piece where one of them conducts the others in different gestures to create simultaneous entrances and attacks. So the communication between the performers is never questioned, and that there's a play between what's being seen on the screen and what's being presented to the audience in the real world.
Yes. So yes, okay, I understand that. And can you just tell me a little bit about software?
Sure. So the instrument itself, the virtual reality and control systems for the Quartet instruments are all built using the Unreal 4 game engine.
Yes.
So Unreal is a very common high-end commercial gaming engine used for games like Fortnite, built by Epic Games. So it's a very battle-tested gaming environment. The audio for the system is all built using Pure Data, an open source workflow programming language written by Miller Puckett. And the communication between the two systems is done using open sound control. So data from the Quartet instrument, from each Quartet instrument, is streamed in real time to the Pure Data audio engine, which then does lots of processing both of the data and contains the models, the STK models of the bowed strings and a number of effects and processes that go into the piece.
Okay, and can you just explain what the process of composing, right? As I understand, you start with this building the instrument, right, and then only, right? But can you elaborate the stages which you go through from I don't know, from that conversation with Marco, right, till till the first performance?
Sure. So in a piece like this, I really think of the composition strategy as being, in a way, similar to software design. It becomes an iterative process, right? So the instrument in its initial state was fairly full-featured before I started composing. But having built the system and actually learning how to play it are two very different things. So as I explored just improvising and learning how one could play this instrument that I had built, I started to come up with different gestures and feel which kinds of musical sounds and possibilities would actually work with the Quartet instruments. So through iteration, I just started composing short studies. And those studies themselves started to focus around the different capabilities of the instrument itself. As if I, as a composer, had never played a violin, and I picked up the violin without any prior knowledge and tried to compose a piece for it. So as I sat and played, I started to figure out different performance strategies and performance practices that sometimes matched traditional instruments and sometimes didn't. And so while working my way through my own instrument, I started to write these studies, and the studies themselves became different sections of what eventually became this second movement of the string quartet, which is what we initially performed in Grâce. So this kind of iteration, and as I'd work on new features of the instrument, and as I'd explore them as an improviser and performer, I then started to get a feel for what real performers might enjoy doing, and then I started drawing out my scores.
Yes. So like you start building software, then some kind of playing with that or experimenting, and then adjusting, and then creating composition, right?
Very much so. Yes. I think it's fair to say that if a designer or a software engineer just built an instrument and never played it, it might be the worst instrument ever created, right? We have to know kind of how these systems are going to work, what kind of gestures, what kinds of sounds, what kind of performance practices are possible and are good, whatever good means in this context, before we actually can say this instrument is finished or is mature in any aspect.
Can you imagine, let's say, okay, the same piece, or maybe creating the same instrument, right? But without VR touch. Let's say, using, I don't know, the game console, right? Which called, I don't know, Kinetic or some other opportunity. Is it VR like a very, very, very necessary part of the piece?
In this sense, it is. So VR is a really fascinating technology. And while it's been around for such a long time, the commercial push towards VR that started with the original Oculus DK1 headsets really put it into the hands of people like me who wouldn't be working in a lab generally with kind of a high-end VR system. What you get in VR is a sense of depth. which is something that you can't really capture using a gamepad and a screen to that extent. And so depth of field and the ability to use that third dimension to control a system is, two-dimensional projected screens and environment. For the quartet instruments, it's very much, the performer can actually move around the instrument as they choose. And I do in some solo pieces, I'm very much moving around the instrument to get different gestures.
Yes.
And to create different sounds and to have a different frame of view and range of motion. All of that would be lost if we weren't in VR. And so the concept of depth is frightfully important when building instruments in VR, and really represents a paradigm shift from working in two-dimensional systems.
You said that you just you somehow tested on your own, or you maybe you give opportunity at early stage to test these instruments to musicians, right? Or not? So how
to a certain extent. So the primary development and testing of the instrument was basically mostly me. As part of the GAP project, Marco and his team, invited me to the studios in Grâce a number of times, at which I started presenting the instruments to the performers. Often, though, just if we would have maybe 3 days to learn the instrument and rehearse with it and explore it before a concert presentation. So, the amount of time that the performers had before any given concert to explore the instrument wasn't really enough to feed back into the development cycle. So most of the initial testing and kind of understanding of the instrument just came from me playing with it. Now, I'm a performer. I've played many instruments my whole life, but I was never a bowed string performer per se of any talent. I was a bad viola da gambist at one point, but I really enjoy the instruments. So as a composer, I have a certain knowledge of bowed stringed instruments, but not to the extent that a performer did. So I was lucky that many of the assumptions and design choices I made seem to translate well for my performers. And so through the GAP project and through the interactions with their performers, I got to test out my ideas many times while the instruments were mature and make changes to them to better accommodate the performers. So all the performers in Austria were absolutely wonderful to work with during the whole project, as was the whole GAP team.
Yes. Just have you tried to build some other piece?
Yes. So I actually have. So after the initial string quartet, I created a new piece using a version of the instrument that was now a double bass. And this piece was called Elegy Ready Set Rapture. And it was commissioned by a wonderful double bassist named Jeremy Bagoyos, who I've worked with over the years. And he premiered it at the International Society of Bassists Conference in, I want to say it was in Indiana. And I actually performed that piece as a soloist myself. And for this piece, it's a solo work for double bass with an extended range greater than the cello and the viola and the violin. And typically I perform the piece with somewhere between 16 and 32 channels of sound, where each individual string is given its own channel and its own speaker in a space, and different effects are added to the sound as well. So it's an improvisatory piece that also included new features for the quartet instrument, including plucked strings, using a new sound model. And that's been a lot of fun to play. And most recently, I've been working on a new iteration of the piece using the bass instrument with composer Matthew Goodhart, one of my colleagues here at Rensselaer Polytechnic Institute, in which the quartet instrument is used to drive transducers attached to gongs, physical gongs in physical space. And we actually did a bunch of work at the MPAC Center here at Rensselaer using their ambisonic speaker arrays and this system of driving transducers in real time. So there's a new work that's currently underway using the quartet instrument in that manner.
And then is it possible, for example, for me or for I'm not composer, for another composers, right? Just to use it, it's like open source, or I can use, or it's like app. Can I use it this instrument for my pieces, or I just can play with that?
So in theory, yes, you could. In practice, it's very difficult at the moment, right? It requires, it's not an easy work to set up and configure. There's nothing inherently personal about the setup that would prevent you from doing it. And I'm happy to work with composers who would be interested. One of my goals, hopefully soon, would be to get a version of the quartet instrument packaged in a way that would be easier for people to perform, to get it on the Oculus Store or the Unreal Store, for instance. But by moving things from this experimental artistic world into an inherently commercial one, a lot of concessions have to be made. The audio engine can't be a separate piece of software. It has to be bundled into the game engine itself. So the complexities, the technical complexities to make it easy for people to use are at this time. It's something that I've begun work on, but for any number of reasons, it still have not gotten to that point. So it's a goal to get this instrument to the extent that you could literally just download it and play it. The full quartet multi-user setup currently still requires a number of machines and some technical configuration. It's not exactly open source in that I haven't posted the code anywhere, but I'm happy to share it.
Right, as I understand, this is just basically a very complicated system what you build, Quartet. And will you do on your own, or there was some other team involved, or there was coder or how many people there were?
It was a team of one.
It's you, right?
So I have a dual background in traditional music composition and software engineering. So I built the entire instrument myself. The models that I used, actually, I want to give credit to my long-term collaborator named Chris Platts, who, if you look back through a number of my earlier works in game engines, Chris and I worked together for over a decade. He's a visual artist. So the three-dimensional models that are used to build the quartet instrument in real time actually come from an earlier piece that he and I created for VR called Carillon, which was a VR performance of kind of a futuristic networked Carillon instrument. It was a concert piece that we'd done over the years. And so the actual models that he created for that are what I used to recontextualize to build the quartet instruments. So the graphical 3D models were created by Chris. I do all the programming and the design and the development and the audio. So it's essentially, this project was essentially a team of one. Chris's assets that we created for the 2015 Carillon project.
And in which kind of, let's say, in which environment, programming environment you worked? Do you use this Max or some other program?
Oh, so the audio engine for this project was all done in pure data. And the game itself in the Unreal Engine, there are two different ways to program in the engine. I ended up using their workflow programming language, which is called Blueprint, which in many ways is similar to pure data or Max MSP, although you can also code the engine in C++. In this case, I did not. I just used their Blueprint language.
Yes. So for creating for creating this piece and these instruments, right? As I understand, right? So you need not particularly you, but like any other composer, right? So he or she or he needs, right, as I understand, coding skills and knowledge, composing knowledge, sound, like sound artist, sound knowledge, and visual artist knowledge. So you need at least 4 competencies, right? Correct?
I think that's fair to say. I mean, designing instruments is a really fascinating idea, of which I would by no means consider myself an expert. I do like to think of this as, in a sense, as digital lutherie, right? It's similar to the idea of sculpting, and creating an instrument with very different concerns and very different limitations than physical lutherie, of course. But it is a challenge nonetheless. So the technical skills are perhaps daunting to many, and I think many people would approach this type of project with a team, which would work just perfectly, I think, with people with different skill sets, whether it's audio engineering and composing, and game design and development. I've been fortunate in my life to have played those roles in many different situations over the years. So actually, for me, it tends to work very well to work in small teams, and generally teams of 1 or 2, and to iterate quickly and get prototypes up and running, and not have to spend lots of time discussing and planning, but instead trying out new things and experimenting.
And what was, like, let's say, the biggest learnings for you during that creating that instrument and the piece? By learning, okay, maybe not learnings, but maybe discoveries, right?
I think the greatest discoveries of this project have been simultaneously how similar it can feel to a real instrument, and yet how far away it is from being that real instrument at the same time, which wasn't something I quite expected. So my initial design decisions, when I first had a prototype that was playable, instantly I got extremely excited because it worked. A number of choices I had made to track the bowing gestures and the actual sound generation fundamentally felt like I was bowing a string. It was very exciting. And then, in order to make the sound more and more like a violin or a cello, I realized how incredibly complex that last step was. To make it sound less like an electric violin and more like an acoustic, beautiful, warm, resonating body, the complexity and the issues around it, in addition to everything else that I was already working on, essentially just felt overwhelming. And so that's essentially where I sit now, is I would love to continue to make these instruments more and more flexible, give them more reality and more features. It's gotten to the point where it's very complex, and there's a lot. In order to get any one of these things more realized, whether it's the sound or the gesture or the graphics, requires itself a huge amount of work, because I've already done all the foundational work. And so that's what's both exciting, in that I feel like I was successful in a lot of my initial attempts, but then realizing how much work there still would be to make this sound, to a regular ear, to make this actually feel like a real violin, is daunting, to say the least.
So there is a huge barriers, right, for creating virtual instruments. They're both
huge
competent barriers, right?
Barrier, yes.
Yes, and then there are, like, let's say, it's very hard to progress, right? Because as I understand, you put one, like, reach one level, and second level is very hard to reach, right? Correctly?
I would think so.
You see, usually
there are a lot
of works different, right?
There are a fair number of barriers to entry to this kind of work. But I think, as technology becomes more and more a part of our lives, younger designers and developers and composers and artists are inherently more comfortable with technology than many of, whether it was my generation or the generation before. So the confluence of these skill sets of people who are comfortable as software engineers and have depth of knowledge and interest in musical systems, I think will only increase because the technology platforms themselves are becoming just kind of a skill set that younger artists pick up naturally. They don't necessarily have to make a decision to be a software engineer in their day-to-day lives as computers take over every aspect of our lives. They generally are exposed to that more and more, artists in earlier generation were. So I think we will see, and we are seeing more and more artists interested in these worlds, whether it's gaming, whether it's VR, whether it's augmented reality or other XR systems that are still coming down the pipe. I think we will see more and more of this, hopefully, as time goes on.
Last question. What would be your 3 suggestions to younger composers, right? From what you learned, or who would like to create, let's say, maybe both, right? One, VR pieces for VR technology, or let's say virtual instruments.
It's a great question. I am a huge proponent of artists being able to understand, control, and generate technology systems. So learning and exploring early how to make music with software and code is a skill set that any musician should want to understand more and more in the 21st century. Whether it's to take your skills as a traditional performer or composer and share them in real time across networks using real-time audio streaming systems, which during the 2020 and 2021 pandemic isolations have become so necessary in order to reach out and connect with other musicians. Whether it's just streaming your sound to others in real time, whether it's leveraging technology platforms to create instruments that can do can leverage our network systems that are all around us these days. The more that musicians are capable of either just speaking that language to work with engineers who have deeper skills than they, or in a perfect situation, the kind of students and researchers I love to work with are people who are multifaceted and who have deep knowledge in all of these areas. So in order to reach levels of complexity in technology and musical systems, I find it really helpful and really necessary to have depth in both of these areas. That doesn't mean that engineers and designers need to work on their own, as I often do, but it gives you the ability to work on these systems without relying on someone else's contribution always. So I encourage all of my students to learn more about technology, learn more about music, and bring them together, because we can do a lot of work here without having to rope others in at the same time.
Thank you very much for this wonderful interview.
Thank you, Sandris. This was great.